Hello guys, how are you doing? Welcome to mathematics, and today we are doing motion, right? In particular, a speed time graph. Okay, in some cases it is a velocity time graph. The difference between the two is that a velocity is a vector, right? It has got quantity and direction, and speed is a scalar. It has got only quantity. Right, but the calculation is the same. So I've got a graph in front of me. It shows the motion of an object, and we need to do some calculations, specifically acceleration, deceleration, and the total distance covered by the object. So without wasting time, let's focus on the question. Right, so on my vertical axis, I've got speed, which is given in meters per second. On my horizontal axis, I have got time given in seconds. So we need to do some calculations. First of all, let us calculate. Let's say the question is as follows. They want us maybe to find, okay, acceleration in the first 4 seconds. Okay, this is the 4 seconds. This is the first question. We need to find calculate acceleration in the first 4 seconds. So in the first 4 seconds, you notice that the object, the speed of the object is increasing uniformly from 0 to 40, right? Initially it was stationary, right? Then it started moving, and there is, as we see, there is uniform acceleration there. There is an increase in speed with time, and the increase in speed with time is constant, okay? So, now let us do the calculation. Our formula is acceleration is equal to final speed minus first speed over a change in time. So, this is our formula to calculate acceleration. But at this point, we need to then remove the words and put values. So my final speed is 40 meters per second. You know, after traveling 4 seconds, the object is now having a speed of 40. So I put 40 there minus the first speed, which is the initial speed, is 0. Okay, because initially the object was stationary. Then the change in time. So it's the final time minus the initial time. So the time is 4 seconds. So if I simplify this one, I get 40 on top. Okay, then I get 4 at the bottom. Making some divisions, I get 10 meters per second squared. So this is the acceleration of the object in the first 4 seconds. Okay, let us now move on to the second question. The second question, they want us to calculate deceleration. Okay, so we need to calculate deceleration. Okay, and you know what deceleration? It is the opposite of acceleration. It is a reduction in speed with time. Okay, so deceleration, the formula is the same. So it's final speed, okay, minus first speed, okay, over change in time, and my final speed. Now the final speed is 0 because you notice the path in terms of speed of the object. Initially you have got acceleration, then there is constant speed, then there is deceleration. So the final speed, as we see, after 12 seconds is 0 meters per second, minus the first speed, which is the initial speed. It is 40. It maintained a speed of 40 meters per second for about 6 seconds. So the first speed here, looking at this top part, is 40. That is the first speed over the change in time. The change in time, right? When the speed was 40, the time was 10, right? And when the speed was 0, the time was 12. So what you do is you basically subtract 12 minus 10. Okay, so it's 12 minus 10. Okay, so on top you get minus 40, and at the bottom you get 2. Now when you divide the top and the bottom part, so you get minus 20, right, meters per second squared. Okay, now the negative sign exhibits a deceleration, right? It shows that there was a decrease in speed with time. Always remember that. So this is how you calculate deceleration. Now let us move on to the last part regarding this this graph. We need to calculate the distance. Okay, the distance. Okay, the distance covered by the object. Covered by the object. Okay, and for us to calculate the distance covered by the object, we need to calculate the area under the graph. We need to calculate the area under the graph. If I look at my graph, I see that it is a trapezium. So I can use the formula of a trapezium to calculate the distance covered by the object. If it is difficult for you, you can partition the graph into 3 parts. You can make a triangle, a square or a rectangle in the middle, and another triangle. You find the respective areas, then you add them together. The answer should be the same. So in this case, I'm going to use the formula for a trapezium. So area of trapezium, it's AB plus CD in brackets times height divide by 2. Okay, so now I will take my AB as the bottom part of the graph from 0 to 12. So that is 12. AB is 12. CD is the top part of the graph, right? So 10 and 4. So from here to there is 6. Okay, 6. The top part is 6. Okay, then I put in brackets. I multiply by my height. My height is 40. My height is 40, and I divide by 2. If I add what I have is 12 plus 6, I get 18. So it's going to be 18, right, times 40, okay? If I multiply 18, then at the bottom I put a 2, okay? If we multiply 18 by 40, we get 8 and 4, 32. So we get 720. 720 over 2. Okay? So the top part, if we do some multiplication, 18 by 40, we get 720, right? Then below we have got 2. So if we divide the 2, we get our answer is 360 meters. So this is the distance that was covered by the object, right? So calculating the how to calculate the distance covered by an object, you find the area under the graph. So today we looked at acceleration, deceleration, and the distance covered. So with acceleration, the formula is change in speed over change in time. With deceleration, the formula is the same. The difference is that deceleration has got a negative sign. Okay, and distance is area under the graph. I hope you enjoyed the presentation. See you next time.